right, in section 5.3, we're going to be continuing our discussion on factoring, and this time we're going to talk about a technique I like to call bottoms up, but there are lots of different techniques that teachers use for this type of factoring. This is just one of them, okay? Now remember the 7 steps of factoring. Anytime we ask you to factor anything, you should be following these 7 steps no matter what. Remember, number 1 is to put it in order, highest exponent to lowest. Number 2 is to look for that greatest common factor. After that, you're going to determine how many terms the polynomial has, whether it has 2 terms, 3 terms, or 4 terms. If it has 2 terms, you're going to try to factor it with the difference of squares or a sum or difference of cubes. If it has 3 terms, then you're going to factor it either with basic factoring or what we call bottoms up. And if it has 4 terms, we're going to use our grouping technique. Now, we've talked about a lot of these techniques already. And so now we're going to talk about bottoms up. What is the difference between a basic factor problem and a bottoms up problem? Well, let me show you. Now, there are so many different rules and so many different steps to follow with all of these different math problems. So I've come up with my own steps to follow when we do bottoms up. And you've heard of, I'm sure you've heard of, please excuse my dear Aunt Sally, PEMDAS. Well, I've made up my own for bottoms up. It's my friend doesn't read books. You can make up your own if you'd like to, but these are the kind of the steps or the letters to follow. M means you're going to multiply. You're going to take their first leading coefficient and multiply it to your last term. You're going to factor just like normal, a basic factor problem it's turned into now. You're going to go back and divide by whatever you multiplied, your leading coefficient that you multiplied by in the first place. You're going to reduce your fractions, and then you're going to bring the bottoms up. Let me show you. My friend doesn't read books. Here we go. So looking at example number 1, when it asks us to factor, we should follow those same 7 steps. Number 1, is it in order? Yep, it looks like this one is. Number 2, is there a GCF? Is there a number that can divide into 3, 10, and 8? I don't think so. And I can't take out an x from every single term. So then I'm going to move on to see how many terms there are in this problem. Well, I notice that there's 1, 2, 3 terms. And if there's 3 terms, I'm either going to do basic factoring or bottoms up. And if you notice, this doesn't quite look like a basic factoring problem because there's a leading coefficient other than an invisible 1. When a basic factor problem typically has a 1 in the front that you can't see, so it just looks like an x squared. If there's a number in front that you can't GCF out, that's our clue that it's going to be a bottoms up. So we're going to follow the steps. My friend doesn't read books. We're going to multiply. We're going to take the 3 away and we're going to multiply it by the last term, the 8. So now my polynomial looks like this. I have an x squared minus 10x minus 28. Now I'm going to factor. This now looks like a basic factor problem because there is no number in front, or there's really just an invisible 1. So let's basic factor it. Let's figure out what numbers multiply to negative 24, that when you add them together you get negative 10. I got negative 12 and positive 2. They multiply to negative 24, but they add to give me negative 10, right? All right, now be careful. You're not done. Some students make mistakes here because it looks like it's factored, but it's really not, so be careful. We still need to do DRB, divide, reduce, and bottoms up. Divide means we're going to go back through and we're going to divide each number by what we multiplied by in the first place. So in this case, we're going to divide by 3. I'm going to divide the 12 by 3, and I'm going to divide the 2 by 3. I'm then going to reduce. 12 divided by 3 is 4. And 2/3 can't be reduced, so I'm going to bring this bottom up in front. And so my factors turn into x minus 4 times a 3x plus 2. Those would be the 2 binomials that FOIL out, that multiply, to give me my original problem. If you're not sure, you can always FOIL out, double check, and make sure you get the same thing that you started with. You should. But the 2 factors you should end up with are an x minus 4 and a 3x plus 2. Remember, it doesn't matter the order that you have those in, as long as you make sure that they look exactly like mine with the same signs. Let's practice another one. Looking at B. It's in order. I don't think there's a GCF, right, between 10, 37, and 7. And it looks like there's 3 terms. And there's not only 3 terms, but there's 3 terms with that number in front. So that's our clue that it's going to be bottoms up. My friend doesn't read books. It's always helpful for me to put those letters down and cross them off as I do them so that I don't forget any steps. So let's multiply. Let's take the 10 and multiply it to the 7. My new polynomial turns into x squared plus 37x plus 70. I'm now going to factor. just a basic factor problem now. I need to figure out what numbers multiply to 70, that when I add them together, I get 37. You might have to list a few factors, but figure out what numbers multiply to positive 70 that add to positive 37. I ended up getting 35 and 2. That multiplies to 70, but adds to 37. Now be careful, we're not done. We still have to divide. So let's go back and divide by whatever we multiplied by in the first place, which is the 10. So let's go back and divide each piece by 10. Let's reduce. 37 divided by 10 are reducing both of those, and then 2 and 10 reducing each of those. So it looks like on this first one, 5 goes into 37 7 times, and 5 goes into 10 twice. So I get 7 over 2. It looks like 2 goes into 2 and 2 goes into 10, so I end up getting 1/5. So I've reduced. And now let's bring those two bottoms up in front. So my final answer, factored, would be a 2x plus 7 and a 5x plus 1. If you FOIL it out, you should end up getting the polynomial we started with. My friend doesn't read books. Let's do one more. All right, factoring. Number 1, is it in order? Looks like it. Number 2, is there a GCF? Ooh, this one happens to have a GCF, so you have to make sure that you do that step first, or your final answer will probably be incorrect and missing that GCF. So let's GCF. Let's leave our leftovers. So my new polynomial is 12x squared minus 38x plus 20. But now be careful. I only took out a 2. Now, is that the greatest common factor? Because if you look, doesn't it look like these numbers still are all even, and it looks like I can take out more? So if you only took out a 2x, it's probably not good enough. It's not the greatest common factor. So be careful. Make sure you take out the biggest amount that can divide into all of those numbers evenly. So I can take out another 2. That leaves me with a 6x squared minus 19x plus 10. And so now it looks like I can't factor anymore. And so really my greatest common factor should have been a 4 and an x, not just a 2 and an x. So that's kind of a way to double check that you've got the biggest number, that if there is a number that you can still take out, then you need to take out more. Okay? All right, now my polynomial inside, we need to see if we can factor even more. Since I have already taken out the biggest common factor, the greatest common factor, and there's 3 terms left with a number in front, that looks like it's a bottoms up. So here we go. My friend doesn't read books. Let's multiply. Let's take the 6 and multiply it by the 10. Let's do our basic factor. So what numbers multiply to positive 60 that add to negative 19? Ooh, that one's kind of hard. You might need to list a few. I ended up getting a negative 15 and a negative 4. Negative 15 and negative 4 give me a positive 60, but when I add them together, I get negative 19. That's multiply, that's factor. Now we still have to divide. What did we multiply by in the first place? Remember, we multiplied by a 6, so I've got to go back and divide each term by 6. Let's reduce. So I reduce the 15 over 6 to 5 halves, and I reduce the 4 over 6 to 2/3. And now let's bring those bottoms up. I ended up getting a 2x minus 5 and a 3x minus 2, but don't forget you have a GCF in front that is part of your answer. If you left off the 4x, that is not the correct final answer, because you need to make sure that you have that term outside so that if you were to FOIL and distribute it, you would get back your original problem. So that 4x is really important. So you should have 3 factors in the end: a 4x, a 2x minus 5, and a 3x minus 2. With the GCF and a little bottoms up at the same time. All right, practice a few of those before we continue, and then we'll get a little more complicated here in a second.